Hi, so today we're going to talk about organic reactions. There is a graphic organizer available to you either in the description of this assignment or in Canvas that you can print out and fill out instead of writing all the notes, or you can make a copy and fill it in the actual Google Doc in your Google Drive. So we're going to identify 9 types of organic reactions, just like early in the year when we talked about single replacement, double replacement, synthesis, so on and so forth. There's other types of reactions besides the ones we've covered so far. Here are the 9 types of organic reactions we're going to cover: addition, substitution, fermentation, esterification, combustion, which you already know, polymerization, esterification, saponification, and cracking. Addition reactions. So addition reactions, we're adding an atom to a molecule. Specifically, we're looking at unsaturated hydrocarbons, so a hydrocarbon that has at least one double or triple bond. Atoms are going to be added at the site of that double or triple bond. Typically, we're looking at halogen atoms getting added to alkenes or alkynes to form halide molecules. And here is an example of an addition reaction. So we're taking an alkene, a double bond, a halogen such as bromine, and both of those bromines get added at the site of that double bond to make single bonds with both bromines. So a couple key things here. Your product, or your reactants, your reactant is an alkene or an alkyne. A halogen is getting added, and you end up with a saturated molecule. Substitution, it looks very similar to addition, but is different. This is where a hydrogen atom on a carbon chain is completely removed, and another atom or side chain is added in its place. So instead of being added across a double or triple bond, we're entirely taking off an atom or chain and adding a new atom or side chain. Halogen atoms get substituted onto alkanes to form halide molecules. So again, it looks very similar because typically this is occurring with halogens. But key thing here, we're starting with an alkane, not an unsaturated hydrocarbon. A halogen is getting added. This could be bromine, iodine, chlorine, so on and so forth. And one of the hydrogens is being swapped with one of the chlorines, and you end up with 2 products. You have 1 chlorine added, and you also end up with the hydrogen that came off of their original molecule bonding to the other chlorine. So you end up with 2 products this time. So key difference here is your reactants, you're not starting with an unsaturated hydrocarbon. Fermentation, so this is the reactions of sugars in the presence of yeast or zymase enzyme that produces carbon dioxide and alcohol. So you should be able to recognize this reaction. You're starting with sugar, C6H12O6, and you're producing an alcohol. It has an OH ending because it has 2 carbons. It's ethanol and carbon dioxide. This reaction, especially if you're going into college or AP Bio, you should make note of this one. You'll see it again. But again, sugar, again an alcohol and carbon dioxide, fermentation. Esterification is the reaction that produces ethers. So it's the reaction of 2 primary alcohols that result in the production of an ether and water. This is also considered a dehydration reaction because during esterification, the alcohols are dehydrated, water is produced. So anytime water molecules are produced, something is being dehydrated. In this case, it's those primary alcohols. Primary alcohols are attached to an N carbon. So here we have 2 primary alcohols which react and they make an ether. Again, an ether is the functional group where it has a side chain of carbon on either side of an oxygen, and it makes water. Combustion, we should already know this one. This is a reaction of an organic molecule reacting with oxygen to produce heat, carbon dioxide, and water. Again, the main thing here is you have a hydrocarbon, or that organic molecule, and its products are carbon dioxide and water. Combustion reactions are exothermic. They have negative delta H values because they're producing large amounts of heat. One of the key phrases for recognizing a combustion reaction is it would have the phrasing burning in the presence of oxygen. And here's an example of a combustion reaction. So we have a hydrocarbon, propane, burning in the presence of oxygen to produce carbon dioxide, water, and heat. Polymerization. This is a reaction in which a long-chain organic molecule, usually called a polymer, are made from smaller organic molecules called monomers. So polymers are made up of smaller repeating units called monomers. The monomers that make up a polymer tend to be the same molecule. Again, it tends to be repeating smaller units. Water tends to be a secondary product of polymer reactions. Sorry about that. But here we go. So these would be monomers. We have small organic repeating units that make a polymer. So they come together, and those repeating units make one larger molecule. Another way to note this is that you could have, again, that monomer, and you're going to see N just meaning there's a lot of them, and they produce a long chain polymer. Polymerization is used in industry a lot. This is the process of making plastics. So this molecule right here is ethylene. F meaning we have two carbons, and we have that double bond. When ethylene goes through polymerization, we use a catalyst in order to spur this reaction. It makes polyethylene. And polyethylene is the basis for many of our plastics that we use in everyday life. But again, ethylene would be the monomer, polyethylene would be the polymer, or the larger chain. And lastly, this polymer has a lot of uses, such as the plastics and film, laminating. Some pipes are made of polyethylene, so it has a very wide application. Esterification is the reaction between organic acids and primary alcohols, and they produce a ester and water. Esterification is another dehydration reaction because water is a byproduct or produced. And this is what it would look like. So we have ethanoic acid, or our organic acid. We have propanol, our primary alcohol, and we're going to make propyl ethanoate, our ester, plus water. Again, this is very often used in industry because esters smell good. So to make any artificial smells, such as what you would find in cosmetics, fragrances, body sprays, body washes, so on and so forth, those are esters. There are natural esters as well, but this is how we make things smell good. Saponification is the reaction of a base with a fat that produces soap and glycerol. So this is how you produce soap, and you can do saponification right at home. You can make your own soap. And lastly, cracking. Cracking is the breaking up of large molecules into smaller units. This is the opposite of polymerization. So basically you're taking a very large molecule and breaking it into smaller pieces, or you're taking a polymer and breaking it into monomers, and that process is called cracking. Alright, that's all I have for you today. As always, if you have any questions, let me know. Otherwise, have a good day.